Let's solve the differential equation given by 2xy times derivative of y with respect to x equals to x squared plus y squared. So what we'll do, we will divide both sides of this equation with 2xy such that we have dy over dx equals to x squared plus y squared divided by 2xy. Now, if we consider the function fxy, which is represented by x squared plus y squared divided by 2xy, and when we make the substitution here, x with lambda x and y with lambda y, then we will get back our original function f of x comma y. So when this particular criterion is met, we say that our given function f of x comma y is a homogeneous function. And if this is a homogeneous function, then our differential equation is a homogeneous differential equation. However, we see in this homogeneous differential equation, this cannot be solved by using the method of variable separation. However, what we can do here, if we make the substitution y equals to v times x, then this homogeneous equation can be reduced to a variable separable form. So let us do that. So once we make the substitution y equals to vx, we also need to differentiate both sides with respect to x. So that will give us dy over dx is equals to, apply the product rule. So we have v plus x times dv over dx. So we will use y equals to vx and dy over dx, this new format, to rewrite a differential equation. So this differential equation now becomes v plus x dv over dx, which will be equals to, so we have x squared plus, in place of y we have vx, so this will become v squared x squared divided by 2 times x times vx. So that means 2 times x squared v. What we can do, we can divide both the numerator and the denominator with x squared. So this becomes v plus x times dv over dx equals to 1 plus v squared divided by 2v. We'll take the v to the right hand side. Then we will combine these two terms. So this will give us 2v in the denominator, and in the numerator we have 1 plus v squared minus 2v squared, which is simply 1 minus v squared over 2v. Now, this result can be rewritten as 2v dv divided by 1 minus v squared equals to dx over x. So we see that this is now, our given original differential equation has now reduced to a variable separable form. So that means we can now integrate both sides. To obtain the integral on the right hand side, we can use the method of substitution. For that, we are going to multiply with negative 1. We're just making this adjustment so that our solution to this integral becomes negative natural log of 1 minus v squared. And this will be equals to, so we have dx over x. So this integration will be simply natural log of x plus the constant of integration. See, since everything is in terms of logarithm, so we'll take natural log of c. Now, this can be also written as natural log of 1 minus v squared raised to the power of negative 1 equals to natural log of x times c. All we've done is use the property of logarithm. Now we can get rid of the logarithm from both sides. So this will be 1 minus v squared raised to the power of negative 1 equals to x times c, or simply 1 minus v squared equals to 1 over x times c. Then we make the final substitution. In place of v, we have y over x. So v squared will become y squared divided by x squared equals to 1 over x times c. Now multiplying throughout this equation with x squared, so we have x squared minus y squared equals to x over c, or simply we have c times x squared minus y squared equals to x. So this is going to be the required solution to our given differential equation.